Hello, this lesson is called Specific Heat Capacity. It's one of those things that's actually really quite straightforward, but lots of people get confused about it. So I'm going to try and make it as simple as possible. And people go, is that all there is to it? And it's going to be quite straightforward. So let's have a look at these words. Specific heat capacity. Capacity means how much can something hold. If you've got a pint glass, it has a capacity of 1 pint. That's how much you can put in it. And so the specific heat capacity is a measure of how much heat something can hold. Now I make my own pizzas and I have got a pizza stone. Here is a pizza stone. Now it's a piece of ceramic, like a piece of pottery, and it takes a long time to get this thing hot. But once it is hot, it stays hot for a long time. So I chuck this in the oven while I'm making my pizza dough, and it will sit there for about half an hour in the oven and get really hot. It has a large capacity for heat, a large specific heat capacity. It can hold a lot of heat. It takes a long time to get hot, and once it's hot, it stays hot. So I then take it out of the oven, I put my pizza dough on here, and it starts to cook while I'm building my pizza, because ceramics like this or concrete have got a very high heat capacity. Another thing is stones on the beach. If you ever have a barbecue on the beach, a disposable barbecue on the beach, it's very dangerous just to take that barbecue away, put it in a bin and leave those stones, because those stones will be hot and will stay hot for a long time, and they'll burn people as they walk over them if someone else comes along. So the specific heat capacity is how much heat energy, how much thermal energy something can hold. We're going to go straight to an experiment, and I'm going to show you what I mean by that. So in this experiment I have got two beakers of identical size, identical quantities of liquid in. This one has got vegetable oil, this one has got water in it, and you can see they're both at 20 degrees. Now up here I've got a frying pan which has been heating up, which is really hot. It's actually got a very large specific heat capacity because it's a thick old bit of cast iron. So what I'm going to do is I am going to put the two liquids in here. I'm going to start my stopwatch and we are going to measure how quickly they heat up. So let's just have a look at this. Let's start the stopwatch. These two things going on this very heat on this. So I'll keep this going. I think we might have to sort of cut or speed this thing up. So now you can see that the oil is at 40, seems to have overtaken the water, which is at about 38. So both of these have got the same amount of thermal energy going into them. They're on this big cast iron pan which is nice and hot. So they've got the same thermal energy in them, and yet the oil appears to be heating up quite considerably faster than the water was. And we are back. So you saw from that experiment that we put the same amount of thermal energy into the beaker of oil as we did to the beaker of water. They both started off at exactly the same temperature. They both got exactly the same amount of heat, same amount of thermal energy, and yet the oil heated up quicker than the water, because the water can hold more heat before it gets hotter, so it has a larger capacity for heat. What you will be told in the exam is what is the specific heat capacity of a certain substance, and it has a number. For example, if we had some water and you had a kilogram of water, which is a litre of water, it would take 4,200 joules to get that 1 kilogram of water hotter by 1 degree centigrade. And that's what the specific heat capacity is. How much energy you need to get a kilogram of something 1 degree hotter. And the maths is really straightforward. Some people get confused about it, but it's really straightforward. If it took 4,200 joules to get a kilogram 1 degree hotter, if you wanted to get it 2 degrees hotter, it would just be twice that. It would be 8,400. Or if you had that 1 kilogram and you wanted to get it 2 degrees hotter, Again, it's the same thing, it's just twice as much. So let's have a look at a typical question that might come up. If we have 2 kilograms of water, and you want to get that 2 kilograms of water from 30 to 40 degrees centigrade, and that's a sort of typical kind of question that you'd get. Now, you know 4,200 gets 1 kilogram 1 degree hotter. So to get 2 kilograms 1 degree hotter, that would be 8,400. But you don't want to get it 1 degree hotter, you want to get it 10 degrees hotter. It's gone from 30 to 40. So that would be 10 lots of that. Okay, and that's using common sense, it's not using equations. It's always good to start from a common sense point of view. But you will be given the equation in the exam, and it really, really is straightforward. And this is the equation that you'll be given. The energy that you need to put into something to get it hotter is you need to know how much you've got, what mass it is, what the specific heat capacity, or SHC as I've called it here, and how much hotter is it going to get. So in this case, we have got the mass is 2 kilograms. The specific heat capacity you'll be given, you're always given that in the exams, is 4,200 for water. And you want to get it 10 degrees hotter. It's going from 30 to 40 degrees. And so that's the sum that you'll do. And that comes out at 84,000 joules. And that's as hard as it gets. Specific heat capacity is how much heat something can hold. And it's measured in joules per kilogram per degree centigrade. Okay, see you next time.